Disclaimer: this presentation is created for educational and informational purposes only. All company names, products, and trademarks mentioned are the property of their respective owners and are used here for reference or illustrative purposes only. The information presented is based on publicly available sources, industry reports, and reasonable assumptions as of the date of recording. While care has been taken to ensure accuracy, no guarantees or warranties are made regarding completeness or correctness. This content does not represent any official statement, endorsement, or affiliation with any company or organization mentioned. Welcome back to our software defined vehicle series. In part 1, we saw how SDVs are transforming mobility. Now we'll dig deeper. What exactly is pushing this revolution? Why are traditional automakers suddenly behaving like tech companies? And what market trends are forcing everyone, from OEMs to chip makers, to rethink what a car really is? We will start with numbers, how big the SDV market is and how fast it's growing. Then we'll unpack four key drivers, which are consumers, OEM, business pressures, enabling the tech, and regulations. We'll look at what global players are doing and close with the key technology trends and the challenges to watch. Little bit about me. My name is Prashant Prabodh. I'm working as a software architect, and I have almost 2 decade plus experience in banking and finance, automotive, healthcare, embedded systems, and last couple of years I've spent in Gen AI. Market growth, market size and growth. The automotive software market is exploding. Analysts estimate that software content in vehicle, currently around 10% of the vehicle's value, will reach almost half by 2030. That is a considerable increase. The global SDV ecosystem, including software platforms, connectivity, AI compute, and cloud services, is already over $250 billion and projected to cross $1 trillion before 2035. To put that in context, the SDV industry is growing faster than the smartphone industry did in its first decade. Consumers have no longer see cars as machines. They see them as devices on wheels. They expect their vehicles to evolve just like a phone. New features, new interfaces, safety patches, even performance boosts, all without visiting a service center. OTA updates, over the air updates, voice assistant, adaptive UIs, and application integrations are becoming the new luxury. People value digital experience more than horsepower, especially the younger buyers. Driver 2: OEM and business pressures. For automakers, the traditional 5-year vehicle cycle is now too slow. Tesla releases software every month, so OEMs must retool their engineering and supply chains for speed and flexibility. They're also realizing that software is not just cost, it's revenue. A single car could generate thousands of dollars annually from subscriptions, infotainment, data services, or application stores, app stores. That's why companies like Volkswagen, Toyota, Stellantis are building in house software divisions with thousands of engineers. Technology is now catching up with the SDV vision. Now, automotive SOCs deliver hundreds of trillions of operations per second, enough for L4 autonomy. Zonal EEA with high-speed Ethernet replaces old CAN buses, allowing shared compute and faster updates. Cloud integration and digital twins let OEM simulate, test, deploy the software globally. Virtualization means one chip can safely run multiple operating systems, from safety critical ADAS to infotainment, isolated but still connected. Driver 4, regulations and standards. Governments are now setting strict rules. Under UNECE R155 and R156, every new vehicle sold in many countries must include a certified cybersecurity management system and software update management system. ISO or SAE 21434 defines how cybersecurity should be built into design from day one, and compliance is now a mandatory gate to sell a car, publishing, pushing OEMs to adopt secure software-centric processes. Competition is fierce. Tesla pioneered centralized computing and continuous updates. BMW's new Class A launches in 2025 with SuperBrain HPC architecture. Volkswagen and Bosch are consolidating into uh, Cariad, CARIAD, their own software platform. Toyota is betting on Arene, a developer ecosystem like Android for cars. Chinese OEMs such as BYD and NIO are leading in speed and integration, updating cars in weeks, not months. Technically, the SDV shift is about simplification. Instead of 100 small ECU doing independent tasks, now we are seeing zonal controllers collecting data from sensors and sending it to a central HPC brain. The software runs as service, meaning it can be updated independently, like applications, apps, OTA, and sums ensure that the updates are secure and traceable, closing the loop for continuous improvement. Risks and constraints. All this comes with new risks. SDVs are always online, making them target for cyber attacks. Third-party software increases supply chain risk. Validating millions of lines of code across mixed software safety domain is daunting. And those AI chips generate heat. So, thermal design and power efficiency are now as important as mechanical strength. Digital twins and virtual validations are helping reduce time and cost. Regionally, Asia, especially China, leads in SDV deployment and speed. Startups there launch new models every 12 months and push updates over cellular networks. Europe sets the rules, driving cybersecurity and update standards through UNECE. North America focuses on software innovation, where companies like NVIDIA, Qualcomm, and Google Cloud power vehicle AI and connectivity stacks. To wrap up, SDV is no longer a future vision. It's here and scaling fast. The change is powered by four forces: consumer expectations, OEM business models, technology readiness, and regulatory push. Success in this new era means mastering the software lifecycle, not just hardware manufacturing. And part 3, next part, we will explore how vehicle architecture is evolving from hundreds of ECUs to central compute brains and zonal networks. See you in the next session.